All right, we ready? Next up, well, if it gets to a point, Matt, where maybe it's still out there, maybe I'll give you a hint. But also, too, I'm not going to be like, hey, this is a hint to the idol. Like, I'm going to be sneaky about it. You know, you got to realize, oh, wait, that's something that's out of the ordinary for this class. Maybe he's trying to tell me something, right? All right. All right, here we go. Let's start it off. I got 4 big circle facts for you today that involve arcs and some chords. Tomorrow we're going to do a full. Tomorrow is nothing new. Let's do all the circle facts I've given you. Let's use them in proofs. That's going to be tomorrow's class. So today is learning more facts. Tomorrow, let's use them all in a proof. All right. So circle fact. There's 4 today. I'm going to go through the first 3 pretty quickly, and the 4th one I'm going to spend a lot of time on, just so we get that one down pretty well. So the first one, can you call that circle O for me by putting a center in circle O? Can you make, hopefully you know these angles by now, can you make a central angle AOB in that circle, please? Central angle AOB. Central angle AOB. So hopefully you remember central angles come from the center. So here's my central angle AOB. And now I'd like you to make a second central angle that looks congruent to that first one you just drew. So please make a second central angle in the same circle that looks congruent to AOB. Some of you may have drawn in 1 radius. Some of you may have drawn in 2. It's up to you. I'm just going to draw in another one and call that point C. So call yours point C or call yours point C and D, depending on how many radii you drew in. And I asked that they look congruent. Now tell me they're congruent. Put arc marks there for me. Put some arc marks that show me they're congruent. And here's your first circle fact. If the central angles are equal, so are the arcs. And that's how we mark arcs congruent, just like we mark segments congruent. So if 2 central angles are congruent, so are their arcs. That's today's first theorem. Unfortunately, though, when we start proofs tomorrow, I am not going to have you write this in the reasons column. I have a shortened version. So here's what I'm going to have you write. Congruent central angles. We could start using abbreviations. Imply congruent arcs. So that's what we'll write when we start doing these proofs. And I won't write down number 2, but we reverse it, and that's number 2. If the arcs are congruent, so are the central angles. Before we go on to theorem number 2, can you make a little note next to theorem number 1? Central angles aren't the only type of angles you know about in a circle. What's the only other? There's another type. You got central angles, and you also have inscribed. So just make a note. I don't want to do a separate theorem for this, but these 2 could also apply to inscribed. So just replace central with inscribed. So also can work for inscribed angles. Okay, they also can work for inscribed angles. But we're just not going to write a separate theorem from them. All right, everybody good? So theorem 1, fact number 1 today of many. All right, let's go to number 2. You can call that circle O for me. Draw in chord AB. Now draw chord AB in that circle for me. However you want to draw it, chord AB. And draw in chord CD that's congruent to it. So you should have 2 chords in this diagram, AB and CD, and show me that they are congruent to each other. And here is what this next theorem says. If you have congruent chords, right? If you have congruent chords, the arcs they belong to are congruent. All right, so congruent chords imply congruent arcs. And if you want to mark them, There you go. Congruent chords mean I have congruent arcs. All good? All right, there's 2. Third one. Oh, you don't even have to do any diagram. I drew it there for you. Here's what this third one is saying. Hey, kids, if we have 2 chords that are the same distance away from the center, 2 chords, same distance away, and I don't like that word same distance. Can we get a little more creative? Equidistant, we like to say that. Is equidistant from the center, those chords have to be equal. All right, so 2 chords, you guys see it in my diagram. They have a distance of 8 from center A. Those chords are congruent as long as they're both the same distance away, equidistant away. And I don't have a shortened version. That's exactly what we'll write in our proof. All right, so 2 chords equidistant from the center have to be congruent to each other. Good, no, nothing we have to put here. All right, last one. I'm going to take some time because this is probably out of the 4 I'm going to show you the one we use the most. Can you draw a diameter in for me? Diameter AOB. Circle O again. Circle O. Draw in diameter AB. So as you draw in the diameter, where does it have to go through? The center. Good talk. Yep. Good job, everybody. Make sure it goes through the center. Then I would like you to draw a chord, CD, that is perpendicular to that diameter you drew in. Okay, so do your best. Draw in chord CD that's perpendicular to that diameter. And what can you put on your diagram to show they're perpendicular? I don't want them to look perpendicular. I want them to be perpendicular. What can we put on our diagram? There we go. Our little right angle symbol. And last thing, can you please put the intersection point of your chord and diameter, put a point E there. Okay, put point E where they intersect. All right, so here's what the theorem says. If you have a diameter perpendicular to a chord gets bisected. Oh, that's a word we haven't used in quite a bit. So what's true up here then? Tell me to put some markings right now. If I have a diameter perpendicular to a chord, it bisects the chord. Bisects it. So what other markings can I put up here? And where? If the chord is getting bisected now. Haley?
CE is congruent to ED.
Good. CE congruent to ED. Now let me get fired up here for a second. Not that it's unusual. It is very rare that you guys will see a full diameter drawn in. Very rare. You could see this. Let me get rid of this part right now. You could only see that. What's OB? That's a what? Is it still part of a diameter? Then this still applies. All right? Just because you don't see a full diameter doesn't mean the fact doesn't apply. As long as it's part of a diameter that's perpendicular to a chord, it still works. I'm not even done yet. You could see even less on the diagram. I can give you that. Is OE still part of a diameter? Yeah, so that fact still applies. So don't expect to see a full diameter drawn in every time. You won't. Right? This is probably what you'll see. Part of a diameter that's perpendicular to a chord, it still gets bisected. Still gets bisected. Questions? All right, so there are your 4 facts. Now what I want to do, a couple algebra problems for you, with you. We don't want that. Okay, so here we go. Let's do a couple algebra problems using these facts. Or maybe any circle fact in general, I should say that. Any circle fact is fair game. Woo! All right, so let's look at this first one. We are asked to find segment X. And the 8, just so everyone knows, 8 is referring to the entire chord length. All right, 8 is the entire chord length. Speaking of that chord, what's happening to that chord? Yeah, it's getting bisected. This is what I was talking to you guys about. You will not see a full diameter. You'll probably get this, part of a diameter. Oh, it's perpendicular. The chord is getting bisected. So now I can at least know that's 4, that's 4. Maybe that helps me. I hope it does. Does it help you? Find segment X? Yeah. Now what can I use to find it? Get away from circles and go back to Pythagorean theorem in a right triangle. I don't want to do numbers today because a little less than half of you aren't here, so probably a 50-50 shot. I don't call on anybody. Let's talk about the legs. The legs should be X and 4. Anybody wishing they took Earth Science today, just for this day on purpose? That's it. And then you could go back to biology, just so you could go on the field trip. It's going to be a long day for those guys.
They don't get back to like 6.
Maybe.
That's terrible.
Maybe they get back by then. They're talking like, I've heard 4 to 12-hour traffic jams up north.
I don't think I could spend that much time with one of my classes.
Or how about just sitting on a bus or in a car in a 4-hour traffic jam? No, thanks. It's not worth it. You guys listening to this too, don't worry. It's not worth it. Hopefully, maybe you find otherwise, but X equals 3. And I know you love it when I do this, but I also want what circle fact we just used to solve this. I don't want Pythagorean theorem, and the reason is there'll just be a smooth transition tomorrow when we write this in the reasons column. So how did I know that the chord was getting bisected? Ready? Diameter, and you could still use that term even though it's not a full diameter drawn in, that's fine. Diameter, what's it got to be to the chord? Perpendicular, use your symbol. Perpendicular to a chord bisects the chord. That's what we're going to start writing tomorrow in the reasons column, if we need it. All right, how about 4? And again, I remember anything applies. We've done this unit, anything, not just the 4 we did today. Anything might apply here to find chord X. Certainly not getting bisected here. Adding anything to the diagram? What's up, Zeev?
The 2 radiuses, so
I.
isn't there 2 ways to say it? There's 2 radiuses.
You can, yes. You can say radiuses, but who wants to say that?
Radii.
Whatever you float your boat.
Other 6.
Yep, wait. Any.
45, 45, 90.
Whoa. I wasn't even going to go that far, but yeah. This is a 45, 45, 90, if anybody noticed that, because it's isosceles. I was just thinking plain old Pythag, but we can go. I love it. 45, 45, 90, if you remember the rules. Do you remember them? Yeah, that's the easy. Yeah, that's the quick way, right? Notice that's a 45, 45, 90. You got to multiply the leg by radical 2, if you remember it. If not, we can always rely on Pythag. Way to go, Zeev, showing off. I like it. I know the directions say nearest tenth, but we're in honors geometry. We'll leave it in simplest radical form. And plus our calculator does it for us. And it does come out to be 6 radical 2, whether I use Pythag or 45, 45, 90 rules. Whoa. What did we just use there? Why did we put 6 there? What circle fact allowed us to put 6 there? Make sure you say it correctly. Because we felt like it? Why did we throw a 6 up there?
Or maybe
No, they're not. In life, all radii are not congruent. There you go. I was going to say, I got 5 up here, and I got a 6. In a circle, that need that phrase, and you guys understand why now. In a circle, all radii, or radiuses, whatever you prefer, are congruent. Remember when I shot you guys down before break with the double eyes? All right, here we go. This next one, finding x, piece of the chord. All right, let's start here. What do you notice about both chords? Same distance away from the center. What do I know about the two chords then? They're congruent. They're both 7 units away, so that means if this chord length is 6, this chord length has to be 6. I know the algebra is easy here. It's the theorems I care about. So we good on why both chords are 6. And what is happening to this chord of 6 we just found? It's getting bisected because it's part of a diameter perpendicular to it. So yes, the algebra is easy to get x. I just take 6 and cut it in half. But I want to make sure we have both theorems down. Let's start with the first one. How did I know that other chord was 6? Chords equidistant. Oh, I love that word. Chords equidistant from where? Can't be from anywhere. They got to be equidistant from the center. Yep. Chords equidistant from the center are congruent. And the reason we cut 6 in half, second time we're writing this today, a diameter perpendicular to a chord bisects the chord. Questions? All right, you are on your own for this one. This beast. It's actually not bad. Find chord X. As you look at it, you know what's happening to it. Being bisected, so maybe you could find part of it and double it. There's a little motivation. I do know it's getting bisected. Right, we knew it was getting bisected, so I could double one piece if I could find that piece, though, to double. Any reason why I gave you this radius was 3? Yeah. So draw in another radius that's convenient for you. All right, so if this radius is 3, hey, why don't I draw in that radius, which is 3? Or that radius, which is 3. Now everyone see, I have 2 sides of a right triangle to do Pythagorean theorem. So you are more than welcome to add in different pieces that you know are true, especially if you know the length. Warning, be careful when you're doing Pythag because the 3 is not a leg, it's the hypotenuse. 2 is a leg. And remember, you're only finding half the chord here. This is not going to be my final answer. It's only half the chord. So we got 4. So the half of it is just leave it as the square root of 5. And then you can double it right in your calculator. And I'll just give you 2 times square root of 5. We used 2 circle facts there, I believe. 2, not 1, 2. First one we used in a circle, all radii are congruent. And the second one, how did we know to double it at the end? Third time we're writing this, that we should be pretty good at this. Diameter perpendicular to a chord bisects the chord. All good? Not only do you get to do a proof here today, but also see the eclipse later. This is like a legendary day right now for you.
We'll have
A
the same
proof?
for tomorrow.
And an eclipse. What?
We'll have the same proof for tomorrow.
I wanted to just do one to see how you guys are doing. I didn't want you just, I know some of you just can't wait until tomorrow. Either you wouldn't be able to sleep, all those other issues that go into not wanting to do, wanting to do a proof. So I'm like, I'll give you a little taste right now. And it's eclipse day too. So how can this day, it can't get any better. It cannot get any, it's never going to happen again. Probably for another 40 years. And you guys won't be doing a proof on those days. So, and I probably won't even be teaching it. So this is the moment right now. A proof and an eclipse on the same day. Alrighty, let's go. Here we go. B is the midpoint of AC. Don't get crazy. A midpoint acts the same way for an arc as it did a segment. Cuts it into 2 equal arcs. So right away on my diagram, I'm going to have you guys mark, arc AB is congruent to arc CB. Midpoint works the same way for arcs as it does for segments. And so we don't forget about it because that's a common mistake. I mark it but forget to put it in the statements. Let's put it there. Arc AB is congruent to arc BC. Hey, don't complicate it. What do you think my reason is going to be? Same reason it was if I said segment AB congruent to segment BC. Definition of a midpoint. All right, so don't get freaked out there. Midpoints work the same way for arcs as they do for segments. Take a peek at the proof statement. It says prove A congruent to C. You know what I'm going to say. That's not going to be true until, because A and C are not inscribed. Remember we talked before break, inscribed angles have to be 2 chords on each side, not a radius in a chord. So I'm not using that. Those aren't inscribed angles. So they're not going to get congruent unless I do what first? Triangles. That's on you guys. Give me something. Give me anything. QC and QA. Perfect. There we go. Not taking the easy way. Love it. QC congruent to QA in a circle. All radii congruent. There's a pair of sides, 1 down, 2 more pairs of parts to go. What else up here can you get me congruent? Steve?
Angle AQB and angle CQB.
Ooh, going tough already. And this is, I'm glad we're doing this because this is going to be one of the new ones I showed you guys today. So angle, I don't want to do that. Angle AQB is congruent to angle CQB. All right, ready? Here's what it's going to be. We knew that the arcs were congruent first. So congruent arcs, because we knew they were congruent first, imply, what did Zeev just give us here? What type of angles? Don't just say congruent angles. I need to be specific. They are congruent central angles. There you go. So congruent arcs mean I have congruent central angles. There's an A. One more part. One more pair of corresponding parts. What else could I say are congruent up here? That would make the triangles congruent. I really don't want anything else unless it's going to make the triangles congruent. Go ahead, Ian, get it.
QB.
Yep.
Reflection.
And I want to just mention something after we write this. Quickly, could I have put in that QB was congruent to these two radii up here? No. No. Yes, it's true, but why don't I want all three of them to be equal? You need to list the corresponding sides separately. All right, so QA and QC correspond. They need to be written separately. QB written separately. Okay, I need the corresponding sides and angles all written separately. All right, I think you guys got the triangles congruent for me. Triangle AQB congruent to triangle CQB. What method you have for me? Yep, side angle side. Great job, everybody. Good work. You guys are on fire today. I got the triangles congruent so I could get the angles. And we did do this right before break, so if you forgot, go ahead, let it roll off the tongue again, those 5 letters. Oh yeah, settle down. I can't write that fast. T, whoa, yep. C, good job, yep. I gotta calm you guys down. Oh, I'm not done yet though. I always like to talk about different versions of a proof. This is one version. Now, Zeev gave us the central angles. There is a way to do it without the central angles. Remember arc AB and arc BC? If 2 arcs are congruent, so are what are these here? Those are line segment AB in the circle, line segment BC. Those are what? Chords, right? Yeah. So I could have substituted in AB congruent to BC, congruent arcs have congruent chords, and then we could have done side, side, side. All right, so keep that in mind too. We could have said the chords were equal because the arcs are. All right, you guys are going 5 big problems tonight. I'm laying it on thick, huh?